Today we are going to be discussing transition metals. Somehow you call them transition elements. So we're going to talk about transition metals. Transition metals. Transition metals. What are they? What are transition metals? Do you know that transition metals belongs to the D block of the periodic table? Do you know that? That you cannot find transition metals in the S block. You cannot find them in the P block. You find them in the D block. You can't even find them in the F block of the periodic table. What do we mean when we say that transition metals or elements are found in the D block? What that means is that they are elements that possesses D subshell that have partially or incompletely filled electrons. That's what it means. That is all about it. So it means that transition metals or elements are elements that possesses a D subshell that has incompletely filled electrons. Let us take a look at a hypothetical diagram of the periodic table and see where the D block lies, where the transition metal lies. Do you know that they are transition metals? Because they actually hold two major blocks of the periodic table, the left and the right, that form basically metals, semi-metals, and non-metals. They are the main block of the periodic table. And again, do you also understand the fact that because they are transition metals and possess partially filled or half-filled or incompletely filled electrons in their D subshell, they have the tendency of also forming what? Cations, stable cations. But let us take a look at the periodic table and see how it looks like. This is going to be just a sketch of the periodic table. Now, the periodic table looks like this. Okay, please, I'm not too good in drawing, but it looks like this. And then we have this. So here we have something like this. And then we have another one. And then we have another block in this form. And we have another block in this form. Okay, so we have this. Okay, and we have this. So down here we have another block this way. We have another block this way. And this block we have this way is divided into two. Now, this block that we have here and this other block that we also have here form the very first division of the periodic table. And this is where you have the main block. This is where you have the main block of the periodic table. The main block of the periodic table. The main block elements. The main block elements. And then here we have the transition metals. The transition metals or elements. And here we have the lanthanides. We have the lanthanides. We have the lanthanides. And here we have the actinides. You see, if you take a look at the periodic table, you notice that it has one block, it has a second block, it has a third block, and a fourth block. So it is divided in that way. Four main parts of the periodic table. And the central part here is where you have the transition metal. And that is why here you have metals like scandium, metals like titanium, metals like vanadium, metal like chromium, manganese, okay, metal like iron, metal like cobalt, metal like nickel, metal like copper, metal like zinc. These are the first 10 metals in the transition block. And all these metals, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, are all transition metals. That means that all of them possess an incompletely filled d subshell. It means that they form stable cations. They are reactive. And here you have hydrogen, here you have helium, here you have lithium, you have beryllium, you have boron, okay, you have carbon, you have nitrogen, oxygen, okay, and so forth. So if you take a look at this periodic table, you'll notice that as you are moving from the left across the row to the right, you are moving from where you have active metals, then you are moving to semi-metals, and then you are moving to non-metals. This is how it looks like. So in the periodic table, you have the main block elements that are held by the transition metal or elements, and then you have the lanthanides and the actinides. But do you know that something is funny about this? That there are some lanthanides that possesses some characteristics that looks like the transition metal. Hence, we call them secondary transition metals. But they cannot be part of the transition metals because they have completely filled the orbital. So they are in the f orbital. So you see that here is the f orbital. And here is the d orbital. Okay? And then you have the s orbital. So you can see that you have the s orbital, you have the p orbital, you have the d orbital, you have the f orbital. But it's also worthy of note that there are also transition metals that do not really possess an incomplete or completely filled d orbital. Example, metals like zinc. Okay? Metal like zinc, metal like mercury, metal like silver. These metals have a completely filled d orbital. But why are they still in the transition metals? Because they possess a higher characteristics of the transition metal. Not just because they do not possess the completely filled d orbital or incompletely filled d orbital. So they have completely filled d orbitals, but they remain in the transition metal because they still possess a greater characteristics or qualities of transition metal. And we are going to see the reason as we move ahead. Now, why are transition metals important? Why do we talk about transition metals? As a matter of fact, transition metals are very, very important. Of all the metals in the periodic table, they have a highest boiling point and melting point. They are so hard and also have the highest densities. But that is not all the reason why transition metals are of greater importance. Now let us look at what are the general characteristics of transition metals. Let's see the general characteristics of transition metals. I have to clean this so that we could have space to talk about the general characteristics of transition metals. So while we look at that, we are going to leave the aspect of the transition metal here so that we can make reference to that. Do you know that transition metals, one, they form colored compounds. They form colored compounds. What do we mean when we say transition metals form colored compounds? Do you know that most of the solutions that you see, most of the solutions of compounds, liquid compounds that you find, they have very beautiful colors. Do you know that a lot of them are prepared from transition metals? Take for example, let us look at iron. Do you know that iron, in the +2 state of iron is having a pearl green color. It means that in a +2 state of iron, if you use it to prepare anything, that is to say it is what? Anhydrous. No water or crystallization containing it. You will have a solution that comes with a pearl green color. Do you also know that if you decide to put this iron now in water, let's say iron sulfate, you decide to put it, that is say it is now hydrated, you decide to put it in water, do you know that the color you will get will rather become a violet color? You have a violet color. That means that if you are preparing anything at all and you decide to use iron as a transition metal to prepare that solution, the color you will get will be violet color. Beautiful. So transition metals they form compounds with what? That are colored compounds. Do you also know that iron 3, if you use iron 3, that is the oxidized state of iron 2. If you use iron 3 to prepare any solution, you will rather get a yellowish brown coloration. A yellowish brown coloration. That means you have decided to use the oxidized form of iron 2 to prepare your solution. You will get a yellowish brown color. Did you see what is happening? So most of the colors you see in certain solutions are because there is a presence of a transition metal. How about copper? Do you know that if you use copper, that copper ordinarily has a white color or colorless? It has a white color, colorless. Do you know that if copper sulfate, okay, let's say copper, let me just use copper sulfate. Do you know that copper sulfate in the presence of water, that is to say it is now anhydrous, or rather it is hydrated, it is now hydrated. Do you know that if copper sulfate is hydrated, it is in water, it will rather give you a blue color. So if you prepare any solution and use copper in water to prepare that solution, or copper sulfate in water to prepare that solution, you will definitely have that solution giving you a beautiful blue color. That is the beauty of transition metals. That's what makes them very important. So they form colored compounds. That is one. Now, what is the next characteristics or the next property, general property of transition metal? Do you know that transition metal form stable complexes? They form stable complexes. In our earlier class before now, I had mentioned that complexes have a very strong attractive forces. They form strong bonding. They form very strong bonding. So if you look at transition metals or elements, they form complexes and make themselves a central metal ion. And since they're a central metal ion, they drag ligands to themselves and form strong bonds. Now take for example this compound. This is nickel. This is cyanide 4, 2-. Do you know that this is a complex? In this complex, nickel is the transition metal. This is the transition metal. This is the transition metal. So here, nickel behaves as a central metal ion. So it drags the cyanide, which is a ligand, to itself and bond to it very strongly. And this compound can be named. Okay? So this is tetracyanonickelate 2 complex. That's how you name complexes. This is tetracyanonickelate 2 complex. Do you know that we also have another complex? You can have, this is cobalt, this is an amine group 3+. Do you know that with this we can also name this compound? This compound has cobalt. Cobalt is also a transition metal, and it stands here as a central metal ion. So it's going to bond to the ligand. It gives it a very strong bonding. Okay? And then it forms this compound. Now this compound can be named as well. This is hexaamino cobalt 3 complex. Hexaamino cobalt 3 compound. Cobalt 3 complex. Now you see that transition metals also form complexes, and because they form complexes, they are widely being used, since their complex nature will allow for strong bonding. Take for example myoglobin. Remember that in our last class we had mentioned something concerning iron, that iron is found in hemoglobin and myoglobin, and iron is a transition metal. Iron in myoglobin is found as iron oxide. And remember that myoglobin helps to transport what? Oxygen from the lungs to what? To the muscles. So the iron stands as what? A central metal ion, and it bonds itself to the oxygen. And because of that, it gives the blood a stronger bonding and stability to transport oxygen. So that makes transition metals very, very important. Another general characteristics of transition metal is that it forms variable oxidation state. Variable oxidation state. It forms variable oxidation state. What do you mean by that? It means that transition metals do not have just a unilateral oxidation state. So it can exist either in +2, can exist beyond +2. So at its ground state, it can exist as +2. And in the excited state, it can exist as what? As in +3, as the case may be. And it goes across all the transition metals. So you can see that iron exists as +2, iron exists as +3. Copper exists as +2, copper exists as +3, and so on. And this means that because they can exist in this variable oxidation state, they can take up chemical reactions at different levels. They are not just confined to one level, they can take up different chemical reactions at different levels. That makes them very important. Another unique property of the transition metals, which is our number 4, is that they form what? They form paramagnetic compounds. They form paramagnetic compounds. They form paramagnetic compounds. And the reason why they form paramagnetic compounds is because of the presence of the incompletely filled d subshell. There are no electrons there. Just the same way, the reason why they form colored compounds is because of the d-d transition. Another very important property is that they have what? High boiling point. They have high boiling point and melting point. And also they have what? High density. They have high density. They are very hard elements. They are very hard elements. So they have high density compared to every other element in the periodic table. They have high boiling point, melting point, So you see, transition metals are very important metals. There are other properties of these metals that you will need to go and take a look at after this class. But it's very important for us to know today that in this class, we have known that transition metals belongs to the d block. And this is because they have what? They have a d subshell that has incomplete electrons being filled. And that because of that, they form stable cations. And that they form color compounds because of their DD transition. And also that they have variable oscillation states. They form compounds that are paramagnetic, and they form stable complexes. I'm sure you enjoyed today's class. Quite a wonderful one. Do not forget to like, do not forget to share, do not forget also to subscribe and to follow. Until next class, it's bye for now.